Welcome everyone to Knox Game Design for November 2023. My name is Levi Smith. So this month I'm going to be talking about how to make a card memory game, how to design this and implement a card game. So there's a couple of examples of this card game. If you ever played Super Mario Brothers 3, it was a mini game where you could earn items. And also there used to be an old game show called Classic Concentration where contestants would try to match two cards, and then if they matched the cards, and they would win the prize. So that's what this is basically going to be. This is a good starting game for beginners, something easy to implement that isn't too involved. So the first step is, well, what objects? I'm going to take an object-oriented approach to doing this card memory game. So first thing that you'll need is a card object. We're going to have a card have a type ID, which is going to be an integer, basically a whole number. Then it's going to have a status. Is it face up or is it face down? So as you select these cards, they're going to flip face up. And then if you match two, then that goes to the matched card, and then the game is over once all the cards are matched. The card is going to have a position. So this is going to be a graphical game. You could probably do this as a console game, text-based game, but we're just going to do a graphical version. And starting out, you don't need to worry about card images or visuals. And then you want to have a game manager class object. So that game manager is going to track all the cards in the game. Going to have a collection of unmatched cards, all the cards in the game. And then you can design this a couple of different ways. You can move those cards to a matched card list, move them from the unmatched card to the matched card list or collection as the player matches them. Then whenever all the cards have been removed from the unmatched list or collection, then the game is over, the player wins. A couple of constants that you'll need, and this is just for display purposes. You need to know the max number of cards, so that's not for display purposes. You need to know how many cards, and this could be a variable value, and I implemented this game so you can use a changed actual number of cards. So you're not set to, what is it, 18, and like the Mario 3 example up there. But you do need to know how many cards per row so you can lay out the cards appropriately. So that's just for display. It really doesn't have anything to do with game logic. So when I've done game examples in the past, I usually just get into implementation, which really isn't what you want to do. So for this one, I went ahead and did a state diagram, a couple of state diagrams showing. So the card is pretty simple. So this black circle, that's just the starting state. So each card is going to have like a state machine, FSA, finite state autonoma, or whatever you want to call it. It's called different things. Deterministic finite autonoma. But yeah, it starts out in the face down state. All the cards start out face down, and then as the player clicks a card, then it goes to the face up state, and then by no means of its own control, then it goes back down to the face down after the game manager determines that there's no match. So that's kind of like a null or a lambda transition there. It's controlled by the game manager itself. So here's the game manager. So this is a little bit more complex, but it's good to like diagram this out before you implement that. I kind of think of it as a roadmap. So as you're implementing this with your classes and everything, then you kind of see, hey, these are the states that it goes through. And if you're not implementing according to this state diagram, then you're doing something wrong. So you start it up here in the upper left hand corner with the single black dot So the game manager is going to create a collection of card objects, and then we're going to shuffle that collection. So we're going to start out in the no card selected state. So then the user selects a card, a face down card. Then it goes to the one card selected state. Then the user selects another face down card. Then it goes to the two card selected state. And then it's automatically going to go down to this check match state. So either the selected cards matched or the selected cards don't match. If the selected cards match, then we're going to add the cards to the matched collection. So I'm using the matched collection here. You could just remove them from the unmatched. That's kind of a design decision right there. So if the cards didn't match, then we're going to check to see if all cards match. If all cards are in the match collection, the player wins. And this double circle right here, that's the end state. If the selected cards didn't match, then we're going to unselect those two selected cards, set them back to face down, and then not all cards match. Or assuming if they didn't match, then you still got more matches to do. So then we're going to send the game back to the no cards selected state, so the player can keep playing. So that's kind of like the little roadmap there. Here's some display properties for the card, a width and a height, and a draw method. So by the way, I'm going to check. My example is in MonoGame again. I like MonoGame just because you can get Visual Studio for free. The MonoGame library is for free. The only downside to MonoGame, they don't have a web build, so you can only do desktop builds. I think you can do Android mobile builds. But so then the game manager, you're going to have card spacing and draw. I think some other properties I left off here. Okay, so here's the first step of the example. So I implemented this in 7 different steps to show how this is created. So we're going to create a game manager object, and we're going to create a collection of card objects. The game manager, we're going to set the card position. MonoGame, we're going to create card face up and card face down sprite. So yeah, the bad thing about MonoGame is you have to have a sprite for everything. You can't just draw a rectangle easily. In some other languages like Allegro or SDL, I think may. Don't quote me on that. I know they may have rectangle drawing calls built in. So we're going to import those into the MGBC editor. So yeah, you just double click the MGBC editor in the project hierarchy, and that'll open it up. You can import the sprites. So starting out, we're just going to have like a black square and a white square to draw rectangles for sprites. Yeah, so I just create a static dictionary for all the sprites, so they're all in one place. So makes things easier. Yeah, like I said, other game libraries, you can probably just draw a rectangle without importing the sprites. That's something that could be left as an exercise, as implement this in other languages. So here we go. So we want to draw the cards to the screen. And start out, we just want to draw the cards. You just want to display like how many ever cards that are in your collection to the screen. Starting, that's the first step. If you're not at that point, then you need to stop and go back and just get, like, if you've got 18 cards, you want to draw the 3 rows of cards spaced apart. So here's the card positioning formula. So you got, each card has an index, 0 through max number of cards minus 1. So we're going to, for the X position, we're going to mod cards per row, then multiply that by cards width plus card spacing. For the Y position, we're going to take the card index, divide by cards per row. That should give you a number 0, 1, or 2. multiply that by card height times card spacing. So that's a little bit of magic you need to know there. So I went ahead and like put this in the slide. Basically what I did by default, you get this game 1 class in MonoGame. So we're loading the textures, creating the game manager object, adding sprite batch begin and end, call draw on game manager. So you can see that's why I didn't highlight it or anything in here, but I don't have the magnifier, but that's basically what this does. Got the game manager, creating the dictionary of textures, and then we're loading our card face up and card face down. And we're leaving the update alone. And then in our draw method, all we're doing is calling sprite batch begin, then game manager draw, sprite batch end. So in our game manager, we have a draw method here. So it's going to handle drawing all the cards just to keep things simple, because the game manager has the list of all cards. So I like keeping that within the game manager itself. And we have the constants, max number of cards. Cards per row is going to be 16 pixels between cards. And then I got a create cards method. It's good to have the create cards in its own method, just because later on we're going to have a reset method. So then if we want to reset the game or start a new game, you just call create cards, delete the old cards, and call create cards again. So it's going to leap through and set all the card positions and add it to our cards list. And here's our card over here, our card object. So it's just going to have a type, int I type, which we're not dealing with right now. A boolean is face up, and a position, card width, card height, and a draw method, and a position. So this is what it looks like right here. We're going to have 3 rows of cards. So let me escape out of that, and just to prove, this is it right here. Run memory game, and there it is right there. So this is the first step. Just get 3 rows of rectangles, black rectangles displayed on the screen. And by the way, the that MGBC editor, I did a talk on MonoGame a while back. It has a lot of good information, but you can expand content, and yeah, content MGBC right there. Yeah, so this is the editor. The importer just manages all your resources, so you just got to go in and click plus, add existing items, and you can select your PNG files here. And that gets tied to the in your load content. You just say content load texture, then the name of the texture that you loaded. And I just add that to this texture, static textures collection right here. That way you have all the textures in one place. That way in your card, you can just say game 1 textures card face down. And I don't know, people may have discussions on whether this is the appropriate thing to do or not. It just makes things cleaner to me, having just one textures object. You could probably create a whole different textures class and do it that way. And people may complain about having a static textures collection, but the problem with like not doing it this way is you're going to have to pass a reference from this game 1 all the way through game managers down to card, and it gets to be a big mess. And that's why I just have it as a static right there. Okay, so here's part 2, step 2, do step 5. Okay, so if you got your 3 rows of cards, face down card, 3 rows of just black rectangles that look like cards, and you can move to the next step. So the next step is create a variable to hold the. So we already actually did this, but each card's going to have an ID, a type ID. just be aware that these IDs are reused between cards because it's a type ID, not a specific ID for the card. So this is going to be like, if we go back to the Mario 3 example, go back. So the type ID is going to be like an ID for the mushroom or the star or the flower or the coin number, or like in the classic concentration, it's going to be the prize, phone answering machine. That would be the type ID, and it's not going to be like mushroom or anything. It's actually going to be an integer ID value because we don't want to compare strings. So we're going to assign the ID upon card creation. We're going to increment the ID after every 2 cards. We're going to use a separate variable to hold how many times the ID has been assigned. And yeah, if we're allowing... So I'm not doing this in this implementation, but it may be possible to have an IDs 4 times or 6 times or 8 times. And so if you have 4 mushroom cards, you may have that IDs 4 times or 6 times. But in this example, I'm just going to have each one used twice. And then what we want to do in this step is just draw the ID value for each card. So this is what the code looks like. Yeah, so display the value in MonoGame, you got to set up this font. So it's another MGBC deal. You create that in the content editor, and there's an XML file you can set up with the font. That's all we're going to do in game 1. In the game manager, we're creating the cards, and here's where we're like setting the type ID right here. That's all we're doing. So then we're incrementing the ID count. Then if the ID count is greater than the max shared ID, which like I said is just going to be 2 in this implementation, but you can change it, make it 4 or 6 or 8. You just got to make sure it's not something weird. Actually, you could probably do 3, but you got to make sure that the total number of cards is a multiple of 3. So if you do something weird like that, just make sure you got the right number of maximum cards. So yeah, if it goes over the max shared IDs, then we're going to set it back down to 0. Then we're going to add, so that this is the same, adding the card to the list. So for the card, we're going to just draw the ID of that card, the type ID of that card on top of the card. Then I got a set ID function. So this is what it looks like starting out. So we just want to have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, and 8, 8. So if we go back to the code, so got memory game 2, open that up, and run memory game 2. And I'll put this code out in a source code repository where people can access it. So yeah, here it is. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. That's the next step. But yeah, this is just kind of going step by step, showing how I implement this. No, like, I don't know. If you give somebody, say, hey, go out and implement a memory card game, people may not just know where to start at all. So this is just going through my head how I implement this. And there may be there's probably many other different ways to implement this. This is just how I implement it. One solution to the problem. So the next step 3, memory game 3, is to shuffle the cards. So we need to create a shuffle cards method, create a new shuffled list data structure. This is just going to be temporary. Actually, what I'm going to do is I'm going to move all the cards from the original card list into a shuffled card list, then make the new shuffled card list the card list. So we're just kind of moving the pointer around. then the old card list isn't going to point to anything. And so it's going to be empty, and we're just going to let the garbage collector get it because there won't be anything pointing to it. We're going to select a random integer from 0 to all the card list side. That's how we're going to shuffle it. So we're going to pick a random card out of the all cards list, add it to the shuffled card list. Yeah, that's basically what I said there. After all cards have been removed from the all cards list, and we're going to point the all cards list at the new shuffled list. So we're just kind of moving the pointer over. So we're assuming the empty dereferenced all cards list will be garbage. That's what I just said. It'll be garbage collection. And oh yeah, so if you're doing like C++ or C, make sure you free up the memory. But in MonoGame, we don't have to worry about that if we're doing C#. So then we're going to update. Oh yeah, so once we have the shuffled card list, we want to go back and make sure we update the position of the shuffled cards. Otherwise, the cards won't be moved. Yeah, so this is it. Game Manager. We've got the list of all cards, so we're going to create the cards, then we're going to shuffle the cards, and we're going to reset the card position. So here's our shuffle cards. So it's just a list of cards, and then we're going to have this random value that we're going to call R. So while the list of all cards is greater than 0, so we're going to pick a random card from the list, and then we're going to assign that to this card object, and then we're going to add it to the shuffled card list, and then we're going to remove it from the all cards. So eventually all cards should reach 0 as they're moved from the all cards to the shuffle cards. And then we're just going to say list all cards is going to get shuffle cards. Then at that point, the old list of all cards, it'll be empty, garbage collected, which there isn't anything in it anyway. And then we're going to update the card positions. So we're going to go through all the cards and reset their positions. Yeah, so this is what it looks like in a run. So instead of having 0011, 22, then we got this random 521 876 6700 43. And let me show the example. So here's step 3. So if you're looking at this, it may not look like a memory card game. It's like, oh, well, what's the deal with all these random numbers? But yeah, in a minute, it'll start looking more like a memory game instead of just a bunch of numbers on black triangles. Yeah, so that's the next step, is just to get all the cards randomized and shuffled. So here's part 4, step 4, the card flipping. So this is where you need a graphic interface, get the X and Y position. So we're going to require that the user click on a card. So you get the X and Y position in the mouse click. So we're going to go through all the cards and in the game manager and see if any of the cards have been pressed. Oh yeah, so in C# they got rectangle contains, and you can use the X and Y position to check to see if that card has been clicked. You could have stored the card as a X and Y and width and height. I didn't do it that way, but that's probably one improvement I would make. Instead of having separate ints for width and height, could have just stored it all as a rectangle object. Then you don't have to do the create a new rectangle object. If a card is located that location, and if it's face down, if it's already face up, then you don't want to flip it over. Then you want to set the card face up property to true, and update the card drawing code so that the sprite is changed to face up or alter it some way to show that it's face up. Here's the code. So in the game one, that default class, then we just, in the update, we want to track the mouse state. And if the state's changed from unpressed to pressed, then we're going to do game manager check press. So that's going to, the game manager is just going to loop through all the cards to see if a card has been clicked that location. So then in our card, then we got the check press down here. I'm just passing in the X and Y of the pressed location. And here's where we're creating that new rectangle, X and Y of the card position, width and height. So if the rectangle contains that X and Y, then we're going to set is face up to true. So if you really want to know how this is implemented, well, I don't know how they implement it, but you can actually do your own 2D point in rectangle collision or detection. That's in the 2D collision talk that I did. You can check that out if you actually want to write this yourself instead of using rect1 contains. It isn't hard to write that function, but I just used the built-in contains method. So yeah, here in our card, and we're just going to change it. So we got our card face up and card face down. And so it's two different sprites. Just one's black and one black for down, white for up. So we're going to draw the card right here, color white. Then if it is face up, then we're going to draw the card number with the type ID. And actually, yeah, so here, if it's face down, it's going to be white. If it's face up, it's going to be black. Yeah, so this is what it looks like. So now you can click the cards to reveal the values. So let's show what this looks like. So this is demo 4. Go back up. Memory game 4. Should close the old one. Okay, here's what it looks like. So we're going to start out with all the cards down. So as we click, then it's going to pop up the numbers. So as you can see at this point, we're not detecting any matches or anything. We're just making it so as you click these rectangles, they're going to show the IDs. So that's the next step. Just make it so when you click these, then they show the type ID numbers. Okay. So part 5, step 5, check for matches. So yeah, now we got the card flipping working. Now we want to check for matches. So in the game manager, let's add a collection for holding the selected cards. So there could be a case where you could select more than 2 cards. I'm not going into that. So we're just going to have only 2 cards selected at a time. In this implementation, just like the Mario 3 or the classic concentration. So design decision, state variable. So you could use a state variable with an enum and switch for determining the current selection state, or determine the current state by looking at the selected cards. So I'm just looking at the state by looking at how many cards are selected. I'm not doing an enum because you could go into some redundancy there. Using enums would make it a little bit easier to follow, but I'm not doing that. I'm just checking to see how many cards are selected. Should the game manager determine the current card selection by looping through all the cards? Yeah, that's basically what I'm doing. And count the number of face-up cards. And you can add a check match. Yeah, that's what I'm doing. Adding a check match method in Game Manager to check if the cards are matched. And then if the selected cards match, then add the cards to the match collection, else set the cards back to face down. And always clear out the selected cards after a check match, whether matched or not. MonoGame will return true. Oh yeah, so this is where you need to check the button state pressed before and after. If the on the button pressed, because MonoGame, when you press the mouse, the button state pressed will continue to fire for however long the user presses the mouse button down. So even if they click briefly, you're going to get multiple mouse pressed returns on update. So you got to check between this. It's just like the keyboard. You got to check the state of the mouse before, if it was released on the previous update, and if it's pressed on the next update, then that's the frame that the button has been pressed. So the problem is, when I first implemented this, I would click the first card and then click the second card. Then it immediately, if there wasn't a match, then it immediately select that second card again, because it sees that pressed immediately fired again. So you got to check the transition between the unpressed and the pressed state. So that's why that's there. Yeah, that's why I said otherwise the second card will immediately be selected again after the match. When the second card is selected, the match check will immediately occur. Therefore, so once you select that second card, if it doesn't match, and then you hide this card again, the player will never see that second card, because then it will immediately go back to hidden if they don't match. So what you got to do is you got to add a little bit of delay in there so the player can see that the cards didn't match. Or you could have a check for mouse click to proceed or something like that. I didn't do that. I just have a delay of like a second or two after the second card is selected. Then when the delay expires, check for the match. Oh, you could check for the match. I didn't do that. It's better just to check the match, and then if they don't match, add a delay. Then after the delay expires, then let the player select cards again. That's what I'm doing here. So yeah, this is that mouse state checking code right here in the default class. Game manager. So I got cards selected, list of cards selected, and list of cards matched. Here's that reset delay. So in the game, so we're not even changing the cards. So in the check press, then we're going to check to see if two cards have been selected. Then if two cards have been selected, then we're going to check if they matched. So yeah, this is just a simple quickie. Here's a check match. If the first selected card type ID equals the second, so at index 0. So the first selected card is at index 0. The second selected card is at index 1. If the type IDs of both of those match, then we're going to add those to the cards match collection. Then we're going to clear out the selected cards. Otherwise, we're going to have 2 seconds of delay. Here's the update. If the reset delay is greater than 0, so here's the delay, then we're going to just subtract off. This is kind of like delta time in Unity. I always forget what it is in MonoGame. It's float game time dot lapsed game time dot total seconds. We're going to subtract off that. So if there is delay, we're going to subtract that off. Once the delay gets back down to 0, then we're going to set the selected cards back to face down. Then we're going to reset the selected cards. And did I have a demo for 5? I think I did. I just didn't put a screenshot in here because I don't think you really can't show a screenshot for the reset unless you do an animation, which I didn't take the time to do an animation and all that. Plus, it makes the presentation bigger if you do animations. Okay, so here's step 5. So we select 2 cards. They didn't match. And they go back to hidden. 3 and 5. 3 and 3. So those match. So you can immediately... So the thing in this step, if you got 2 that match... 6, 5. So here I'm going to do 5 and 5. Then I can immediately select the next cards. 6, 5, 2, 2. Yeah, so if you got two that match, then you automatically select the next card. But if they don't match, then you got 2 seconds of delay before you can select cards again. Okay, so now we got matching cards working. We got the flipping working, and we got the matching working. Well, what is the win condition? So the player wins when all cards are in the matched collection. You can check for the win condition after a successful match. The simplest check is to see if all the count of all the cards equals the count of matched cards. Alternatively, you could create an unmatched collection at the start and then remove from the unmatched collection as they are matched. Game is over when all the unmatched collection is size of 0. Yeah, logically, it's easier for me to understand the match collection. You got a collection of cards as they match, you add them to the match collection. So this is like one of those things where it's easier just to program it logically. Maybe more efficient to do them unmatched, I don't know, but logically it just seems simpler to have a match collection. So I went ahead and created 2 game states in here, one for state playing and state win. That way, once you go from state playing to state win, then you quit checking for clicks, you quit checking for flipped cards and all that. So here's the implementation. So yeah, I have a game state right here, state playing, state win. You got a game state here in your game manager. So we're going to start out in state playing. So one reason for doing this is in your raw message, you can just have a switch and state. You can have a state playing. You draw the cards, state win. And we're still going to draw the cards, but we're also going to draw you win and some other stuff. You could have actual separate methods for state playing and put those in their own little functions and not have them in the switch statement. It just depends on how you want to implement that. Didn't change anything in draw cards. Check match. I don't think we changed anything here. Oh, we added the check win after we check for a match. If they did successfully match, then we check win. And then in check win, if the cards matched, list of cards match count equals all cards count, then send it to the state win. So here it just says you win in red on top. So yeah, that's all you need to do is make it say you win. Okay, so the point being is, whenever I'm making a game, then you want to just get the engine, the base game working first and not worry about graphics or sound. When I started making games like 40, 30 years ago, however long ago it was, when I was a teenager, I'd want to add all the bells and whistles first and just start working on graphics and everything else. But you really just want to get the core functionality working. So there's an 8. Oh, 7. See if I can beat my own game. There's a 1. Yeah, it's hard enough playing memory by itself, but when you're trying to do a demo and do memory. 6 is there, 0, 0. So what I like to do is just go through sequentially and try to like remember like 4 at a time if I can. Yeah, so there we go. We matched them all and it says you win. So that is a working memory card flipping game. So it doesn't look pretty, but it is a working game. So when I was doing this, I guess a week or 2 ago, I went ahead and added the bells and whistles to this. So it kind of feels like I made it so it actually feels like a game that I would share with somebody. So here's the bells and whistles. Added these card graphics. So I went and found some free graphics online, and then I took some emojis. I actually changed that sun emoji to something, I think a star or something, just so all these are. I could modify the colors, randomize the colors, and for each of the symbols. Okay, so basically for each card ID of those 0, 1, 2, 3, 4, 5, 6, 7, 8, I changed that with a graphical a sprite. So I took these emojis, turned them into sprites, and basically what I did is, so I got I made all of the sprites just black and white. So then I can use the color tint command or the color option when you're drawing a sprite to change, to set the color. So I can have random colors for each of the cards, each of the symbols. I can have a random color for each time that I play the game. So that adding the colors is. So the other thing I found some like free music. I don't intend to sell any of this, but I did like have put it like a README in there with the credits and all that good stuff, so people can find the original authors and all that. So yeah, here's all the drawing code and all that. So if you look at the game one, so I loaded in all these symbols, images, sprites, and loaded all those into the content MGBC right here. Right here you can see. And then I added card flipping sounds. I got that from I think freesound.org. And I didn't compose the music for this. I just found some music to throw in there. So here it is. Without further ado. That's kind of small, but yeah, memory game. So I'll turn the sound up a little bit. See if I can win my own game. Look at the cha-ching if you get it right, if you match two. Yeah, and these colors are randomized for every gameplay. Okay. There we go. So I added the cheering sound in there. It says you win. That can probably be centered up a little bit better. But yeah, just to prove it now, the shapes are different colors now for each play. So I have the timer saying how long it took. So yeah, what I have on the last slide is, hey, you could add a leaderboard, submit this to the leaderboard. I didn't add a leaderboard just because you have to add text input, and that's kind of a pain to add. That'll take a little bit more work to add that. I think I had the total number of tries there on the win screen, the game timer. Yeah, you could add options, total number of cards, how many cards to match to that you have to match to make a match. And I did add the little simple title screen to that. So anyway, yeah, that's a simple memory card game implementation. Hope everybody found it useful. I'll put the code out there. Anybody wants to take a look at it to see how it was implemented. So anyway, I hope people out there found it helpful. And anyway, appreciate everyone out there listening and watching.